Let's take a look at this problem. Gasoline consumption in the U.S. has been increasing steadily. Consumption data from 1992 to 2004 is shown below. So notice that these numbers, the consumption is in billions of gallons. So the first thing we're going to do is find a linear equation that models the gas consumption. And we're going to use the data from 1992 and 2004. Here's a graph of what this data looks like if we plot it out. It definitely looks linear, but it's not in a perfectly straight line. We're going to learn some techniques later on in order to find what's called the line of best fit, which is going to give us the best line, the equation that's going to be closest to matching all of this data. That's a little more complicated. For our purposes today, we're just going to pick two pieces of data and draw a straight line between them. So we're picking 1992, which is this guy right here, and 2004, which is this guy right here. So if we say take a line and connect those 2 points, oh, that's not what I want to do. There we go, that's a little better. Try to insert a nice line here. And I'm trying to connect these 2 points as best I can. That's pretty close. All right, so the points are pretty close to that line. So basically we're finding the equation of this line right here. All right, so let's think about some of the pieces of information that we need to know in order to write the equation of this line. I'm going to use both of these notations just because I think people are used to these two different notations. These are the same thing. This is the explicit form. The population, which in this case is consumption after n years, is going to be the population that we start with, or the consumption that we start with, plus the common difference multiplied by the number of years. Let me use some color coordination here. Let's do some highlighting. So this B is the initial value, if you're thinking y equals mx plus b, and then the common difference over here is the slope. Those are the same thing. N being the number of years that have passed, that's the same as your x value. And then your output, your y value, is the same as p sub n. So maybe it would be nice to write this y equals our starting value plus however much it changes by, the rate of change per, in this case, year, and x would be the number of years. So you can kind of see how it fits that same pattern as p sub 0 plus d times n. All right, so let's see if we can find some of these values. Let's find our common difference, or our slope, using the 2 points that we said we were going to use. So if we think about a table here, we've got our years. Let's put it over here. Let's talk about n, and then our years and our consumption. We'll just abbreviate that. Okay. So we have to decide what we're going to make year sub 0. What's going to be p sub 0? And since we're starting in 1992, this should say year instead of years. Let's go ahead and make 1992 year 0. We don't want to go all the way back to year 0, meaning like 2,000 years ago. So we pick some year to be year 0, and in this case, because we're using 1992, we're going to pick 1992. All right, so what this tells you right here is that the consumption in 1992 was 110 billion gallons. So therefore, P sub 0, the initial consumption, is 110 billion gallons. So that is our P sub 0 number that we need. Now we're going to look at the next year we were going to do is 2004. Okay, so if 1992 is year 0, then what year would 2004 be? That'd be 12 years, right? 1992, 2002, 12 years. So 12 years from now, the consumption is 136. So to find our common difference, that's the same as our slope. We're going to find the change in consumption divided by the change in years. So that's going to be 26. Remember, that's billion gallons over 12 years. And that comes out to be a fraction or a decimal, 2.16 bar. Maybe we'll just round. See, this is billions of gallons per year, so rounding can make a difference. Maybe we'll just leave it like that for now. Billions of gallons per year. That's the rate of change in consumption. If we kind of look up here, it looks like, you know, on average, maybe it's going up by about 2. Some years is 3 and some years is 1. But this seems like a plausible, reasonable answer for the common difference. Great, so now we've got our equation. Now we just need to write it out, and we are done with part A. So here's our common difference. So we're supposed to write our formula. So P sub n equals P sub 0, which is 110, plus the common difference times n. Or y equals the initial amount plus the slope times x, right? Those mean the same thing. So now what we want to do is use our equation from part A to predict the consumption in 2020. This is where you really have to remember what your year 0 was. So let's go back over to this chart. If we want to do the year 2020, we have to figure out how many years have passed since 1992, because that was our year 0. So what is that, 28 years? I think that's right, 28. So the consumption that we're trying to find would be represented by the variable P sub 28, the population 28 years or the consumption 28 years since we started keeping track. All right, so we're trying to find P sub 28. So by our formula right here, we started with 110 gallons in consumption. This is where the rounding would really make a difference, times 28 years. So when you punch this into your calculator, just put a whole bunch of 6s in there, right? Like 110 plus 2.166666666 times 28. And I get 170 point a whole bunch of 6s. This is, I don't want to digress too much, but if we had rounded this, say to 2.2 times 28, let's just see what a difference that would make. 110 plus 2.2 times 28, that would have been 171.6. So that doesn't seem like a lot, but remember this is billions of gallons. So we're actually, by rounding it, we're actually off by a billion gallons, which I don't know. I think that's a lot. Maybe in the big scheme of things, like as a percentage, it's not that big. And we could talk about percent error versus actual error, all kinds of things to talk about here, but I prefer not to round too much. All right, that was kind of interesting. So there's our answer from that. Gallons per year. Awesome. Always label our answers. Part C, if the trend continues, when will the consumption in 1992 double? So when is asking us for N. How many years before the consumption of 1992, which is 110, when is that going to double, which would give us 220? So what we know now is our output. We know we're looking for N when our P sub N is 220. Okay, so how many years will I end up with a consumption of 220 if I start with 110 and increase by 2.16 billion gallons per year for N years? Why don't you pause the video and solve that equation and then unpause it when you have your answer. If we subtract 110 and then divide by 2.16 repeating, that bar means repeating. I didn't explain that up here. If you don't know that symbol, that's what that bar means, 66666. We get N equals 50.796 blah, 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 or 769, which is about 51 years. Now here I don't mind rounding because we're not going to be doing anything else with this number. I didn't like rounding the 2.16 because I knew we were going to be multiplying that by years, and that would just exacerbate the rounding error. So the answer to when will be about 51 years from 51 years from 2000, no, it was 1999. Remember, that was our starting spot. So that would be, what would that be? Let's see, 8, subtract that off, about the year 2043. About the year 2043 would be the answer. Now, when you're making predictions like this, you're assuming the trend continues. And with a lot of things in life, we might see a linear trend for a short amount of time, and then something will change out here, and maybe it'll level off, maybe it'll start increasing more. So we always have to watch our trends and then reevaluate our data.